Hello everyone, welcome to Core Guides, and today we'll discuss the topic neural network. First of all, we'll look at the AI data caring. Modern AI requires understanding context and semantic similarity within vast data sets, not just keyword matching. Whenever we consider modern AI, it requires understanding context. So understanding the whole context, the whole sentence must be important instead of previously we were using like word to vec. There we were not able to understand the whole context meaning. So modern AI requires understanding the whole context and semantic similarity within the vast data set. Now, second point is vector embeddings often generated by a neural network represent data by meaning, enabling this advanced understanding. Whenever do the now what is vector embedding? Whenever we convert words into numerical format, it is called as embedding, and these embeddings are often called as vectors, and they are generated by, while we are working in the neural network. So they represent the data by meaning and which is required by the modern AI. Now this question is to you guys. How can retrieving data based on semantic similarity rather than exact matches transform information retrieval and AI application? So what are neural networks? That is the ANN. So as per the definition, ANN are brain-inspired computational models using interconnected processing units called neurons are in gene layers. In case of the ANN, we use a neuron. Now, neuron is also called as a perceptron, which has input layer, hidden layer, output layer. So, multiple components are involved in the neurons also. And there are multiple neurons in the case of the neural network. And when these neurons are connected between to each other, the neural network is formed. Now, this layered architecture allows ANN to analyze complex information and identify subtle patterns. This architecture, which is the ANN architecture, which is generally used to perform or to analyze complex tasks, and it identify very minute changes or minute details in the structure or in the data. Now, how does arranging this simple processing units in the layers enable such sophisticated analysis? So, the question is to you guys. Now, fundamental building blocks of ANN. First of all, we'll see the neurons, which are the core processing unit, and they are the connections between them. And they are generally the weights are assigned between two connections. Whenever two neurons are built, some weights are applied and also biases. Now, biases are learnable parameters providing neurons flexibility in their activation threshold. So, biases are generally at the applied at the head of the each neuron, and they are generally describing the they are most important parameter when we are considering the biases as well as the weight, and we update these weights and biases to the update the parameter so we can get so we can reduce the loss and the accuracy will be increased. How information flows in a neuron. Now, if a neuron receives weighted input signals, it combines them upon a sum and adds a bias. So, in case of the neuron, some if there are two neurons and the two neurons are connected with each other, there are some weight paths, and weight actually signifies the importance of a particular neuron. So, and when we often combine the two neurons and we then add the biases to this process. Now, this combined signal is then passed through an activation function introducing non-linearity before being transmitted. Now, whenever we consider the information flow in a neuron, we have to also pass the neuron has to also now the basic neuron is divided into two parts. One is the sigmoid function. One is the activation function. In case of the activation function, we introduce non-linearity, and that is the work of the activation function. How critical is the non-linearity introduced by the activation function for the network ability to model complex patterns? Now, the network layer structure. The input layer receives the raw data, while the output layer delivers the network final process result or prediction. So, first of all, the number of independent variables present in the data set are the number of neurons in the input layer, and the output layer, the neurons in the output layer totally depend on our task. Whether or not we are working with the regression problem, then we may have one neuron in the output. Well, when we have the classification or when we have multiple categories in the target variable, at that point of time, the classes will depend on the data set and the number of categories present in the target column. And there are also hidden layers which are between the input and output, and the hidden layers, this is the learning process is basically done in the hidden layer, and we can introduce any number of hidden layers in the case of the neural network. It totally depends on us, but we cannot also increase the number of hidden layers too much, as the complexity will reduce and the cost will be increased. So that will be the important point to remember for you guys. Now, fine tuning the network. We can fine tune the network here by using Keras also. So we can adjust the weights and biases, and when we adjust the weights and biases, or to update the accuracy or to increase the accuracy and decrease the loss. At that point of time, we need to fine tune. And if we are facing the overfitting issue problem, then at that point of time, we need to consider the number of layers we have used, the number of neurons in each layer, the activation function which we have used, the optimizer which we have used. So it totally depends, and we can get the best values by using the Keras tuner. And this is all the fine tuning part of the neural network. Now, iterative learning. In case of the neural networks, epoch is passed. After each epoch, if we pass the number of 10 epoch, then 10 number of iterations will be done. And one epoch will consider all the data points in the data set. And in case of the iteration, it can be a processing batch of data. If we are considering the iteration, a batch of data is considered, and epoch is the total number of iterations or total number of data points covered in batch of iterations. So in one epoch, all data points are considered, and iterations is the batch of data. Now, back size impacts the memory and learning smoothness, while error measurement guides with adjustment. Now, whenever we pass input in one go, that is the gradient descent, and in that point of time, we are facing with the learning rate issue, and also if the data set is too big, we are not getting the good result. So at that point of time, we use batch size to divide the data, and we then create batches and then feed the data to the model. So batch size is really helpful when our data set is very big. Now we have the diverse neural network architecture. We have the feed-forward neural network. We have the recurrent RNN to store the sequential data. We also have the LSTM, GRU, which are generally used for sequential data like text or time series. We have also the convolutional network, which are used for images, and generative adversarial network, that is the GAN, which creates a realistic synthetic data. So these are the multiple type of neural network architecture. Now, the core applications or use cases of the neural networks are we can use for a classification as well as aggregation task here. In case of the ANN artificial neural network, we can use for the tabular data, for the tabular data. For the RNN or for the textual data, we can use the RNN, LSTM, GRU, which are used by the sequential data. And for the image, we can use the CNN, which is a convolutional neural network, and which can be used for the image classification or identifying the image. So multiple tasks are covered under the recognition. So this is the part of the neural network, the prior presentation where we have got introduction, and we now will move towards the implementation part. Now we'll see the implementation part using the neural network using the TensorFlow. First of all, we'll import the libraries, which is NumPy and Pandas. Pandas. Then we'll get the data set. We'll use the California offspring. We'll copy path. We'll see our data frame look. So we have 17,000 rows and 9 columns. We'll check the step again. Yeah. And we'll see head to see first 5 rows of the data frame. Right. We'll see the tail. We'll see the missing values. For that, we'll use df dot is na or the line value. So no line values are present here. Then with x, we will keep the independent variable. So for that, we will drop this target variable, which is the median house value. This is our target variable. So we'll drop that, and we'll get all the independent variables. So for that, we'll use df dot drop, and we'll make a column equal to median house value, right? And then in y, we will get a target column, median house value, right? Now we'll see our independent variables too. Okay. We don't have the target variable yet. We'll see the y. Now we'll fill the data. For that, from sklearn dot model selection, we'll use the print is fit. Print is fit. Now we split the data x string comma x test comma y string comma y test y test, right? String test split will mention our independent variable x comma target, and will mention the test size 0.2. Okay, now we'll see our experiment. We have 13,600 rows in our training data for the independent variable. Now we'll scale this data. So we'll use standard scalar for that. From sk learn dot preprocessing import standard scalar. Now include getting is equal to standard scalar. Now we'll standardize our data. Explain equal to scaling dot fit transform, and we'll pass that explain, and for x step scaling dot transform will pass x step, right? Now we'll see the TensorFlow part. From TensorFlow import Keras, then from TensorFlow dot Keras import sequential. For layers we'll use from TensorFlow dot Keras dot layer import then. Now we'll see step for model building in TensorFlow. Step for building model in TensorFlow. First step is defining the model. Second one is adding layer. Third is compiling the model. Fourth is fit the model. Fifth is evaluation. And sixth is prediction. Making prediction. So these are the steps, and we'll follow the steps to build our model. So first of all, we'll define the model. Model is equal to sequential. Right now, for adding layers, first of all, we need to add the neurons for our input layer. So we'll see the shape, whatever the independent variables are there, that are the total number of neurons which will be passed in the first layer or the input layer. When we press or when we get the output as from the independent variables, we have eight columns, and each column is an independent variable. So we'll have 8 input variables in our input layer. So for that, now for adding layer, we need dense layer for adding each layer in the case of TensorFlow. So model dot add will do dense. Then our this is our first layer. This is input layer. So we'll pass the number of independent variables as the number of neurons in the first layer. So for that we'll use x dot shape and 1. Okay. Now we'll use the activation function. Here we'll use the ReLU. Now, we have multiple activation function here. We have ReLU, we have sigmoid. So for most of the part, we use ReLU because it avoid the dropping the learning rate, which is dropping after some calculation, is drastically controlled by the activation function of ReLU. So we use the ReLU activation function. Then we'll see the input dim x dot shape and 1. Now we'll add the hidden layer here. So model dot add then 512 neurons here, and our activation function is also used to control the output of any neuron. So That is also other function of the activation. We'll add another hidden layer. Then this 32, and here also we'll mention the activation function as value. We also have 10H, we have sigmoid, so multiple activation functions are there. You just need to use, in case of the ReLU function, it is also called as a rectified linear unit. It is mostly used for regression tasks, and as our problem is regression one, so we are using that part, the ReLU activation function. Now we will add the output layer here. Now, as it is a regression problem, we'll add only one neuron, right? Now we'll see the summary of our model. Okay. For the first layer, the input layer, we have the parameter 72, right? And for the second hidden layer, first hidden layer, we have 4608 parameter. For third hidden layer, for second hidden layer, we have 16,000. And for the output, we have 33 parameter. Now we'll compile our model. So for that, we use model dot compile log equal to log. We use the MNP, that is the mean squared error as the regression tab. For optimizer will use add up and metric will be MNP. Now in case of TensorFlow models, now log is which we want to reduce. Optimizer is the model which will minimize, which will minimize our log function, and third will be the metric which we use for evaluate. So this is the different components we use in the compiling of the model. Now we'll fit the models. Model dot fit. Here we'll pass the train white ray. Then we'll pass the batch size. Which will be equal to pick 10. We should always give batch size in exponent of 2. So it can be 2, 4, 6, 8, 10. So likewise. And epoch we would give 10. Total 10 number of loops we will do over our data set. We'll try to fit our model now. So starting with epoch 1. Now for fine tuning or evaluating the our hyperparameter tuning the parameters here, like the number of layer we are using, the number of neurons which we are using for each layer, the type of activation function we are using, the type of optimizer we are using, type of log function we are using, the metrics. This all can be done using tuning of this neural networks by using the Keras tuner, and we can get the best values. We can find out how many number of layers should be best for a number of hidden layers should be there for a neural network. For each layer, for each hidden layer, what number of neurons should be there. So we can get the good accuracy from the model, and overfitting issues and underfitting issues are solved. So multiple tuning can be done in neural network also, which will be seeing in the next section, and we will see how we could increase the accuracy and reduce the loss. Last we'll do the y prediction model dot predict, and we'll pass the next step. So these are the results given by the model. Hope you guys understood the implementation part, and we'll see the tuning part in the next section. And if you have understood this section about the presentation and the implementation of the neural network TensorFlow, you guys can like the video and subscribe our channel, and see you in the next section. Bye.